Okay, so let me start the class now. Okay, so in this lab, we'll be studying on plotting in MATLAB. Okay, so I'm sure by this time you know a little bit more or less about plotting, right? So are you guys familiar with basic plotting? I'm sure you have a little bit of idea by this time, right?
Yes.
Okay, but still, we'll go through the basic first. So first of all, obviously, the MATLAB plotting is very much important in even in your later in your thesis or in your projects. You need this plotting things to visualize your data, to understand the trend of your data. All these things will be easily analyzed using the plotting. So there are several basic plots in MATLAB, for example, the line plot part. So we'll in this class we'll talk about little in about the basic plots in MATLAB. That is, there are line plots, then scatter plot, histogram, bar chart, and these things. And then we'll study a little bit about 3D plot and some special types of plot. For example, here we have geographical plot, and we'll also study how we can create videos or GIF, GIF, whatever however you pronounce it. We'll study a little bit of about these things. Then there will be 3D plots also. So 3D plot is not that important, so I'll just skim through this, and also these geographical plots. We'll skim through these things a little bit. But the important thing is that if you know the basics of plotting in MATLAB, it will be enough. That how you can customize the plots. If you know these things, it will be enough. And the main helping hand in plotting in MATLAB is your documentation. So you don't need to memorize anything. If you just simply go to the documentation, you'll find a great deal of examples from which you can actually create a good you can create a very good plot in MATLAB. For example, if I go to this plot, you see there are there are a lot of examples here. Okay, so if you just go through these things, it is very easy to understand how you can customize the plots, and you can easily create a beautiful plot for your data or anything. Okay, so we'll study, we'll visualize some real life data little bit in the class, but first, uh, let's go through the basics of line plot. Again, can you guys hear me clearly? I'm just making sure because now I'm taking the class from home. That's why.
Yes, sir, we can hear you
Okay,
clearly.
very good. Okay, if you guys face problem hearing me or seeing the screen, just immediately ask me. Okay, notify me immediately. Okay, now, so what is this line plot? You see, wait, another thing. So you know the basics plotting that there will be some uh, there will be a y-axis and there will be an x-axis, right? This will be your x-axis and there will be your y-axis, and there will be some data points in your x-axis and some data points along your y-axis. So you plot this x comma y values in this plot in this graph, right? So you have some x value, for example 3 comma 4. Then you'll plot it like this: 1 2 3, then 4, 1 2 3 4. In this way you will plot something, right? Plot a point here. So in this way you can plot several points similarly in MATLAB. And what your line plot will do is that it will place these points in your graph and add and connect these points with a straight line. Okay, so if I just go to uh, where is MATLAB? So let's say if I have take some data, say x equals to 0, 1, 2, 3, 4. Okay. And then we have y equals to, let's say, 3, 4, 5, 6, 7. Now, if I write plot x comma y, you can guess what it will show, right? Why is it taking a lot of time? Okay. So in your script, when you write something like this, so if you run the script, you see a figure two window, a window will open with your figure. Okay. So this is your x, y plot. Okay. So these are your x values and these are your y values. So the first one, that is the syntax of plot, is that the plot xy, the first variable should be your x-axis variable and the next variable should be your y-axis variable. Okay. So that means what? We have written x equals to 0, 1, 2, 3, 4. So at 0, the value of y is what? 3. 0, comma 3. Then 1, comma 4. Then 2, comma 5, 3, comma 6, 4, comma 7. In this way, your plot will, your function plot will plot your values, the points in this way and connect all these points. For example, see if I take my cursor here, you see it shows you the point x 0, comma 3. If I make it full screen, see x 0, comma 3, then you have 1, comma 4. You see, this is 1, comma 4. So you have 1, comma 4 here. Then you have 2, comma 5. See, if you go to this point, you'll see 2, comma 5. In this way, you can mark these points here. Okay. So this was your basic plotting of two variables x and y, that you can visualize any continuous function or trend. Okay. So similar way you can plot your VI curve or your sine wave plots, things like that. For example, if you consider this is x equals to, this is your voltage value, then this is your current, and if you plot this, a new window will open, and this is your VI characteristics curve. Okay, as it's supposed to be a straight line. Okay, then you have, you can actually change this. Let me. Okay, so you can actually change the way the plot looks from this point here. See, if you can change, you can insert some x label here, for example, for the x-axis. You see, and you go to insert and then click on x label. You'll find that you can write the name of the x-axis, the label of the x-axis here. So if I write this is as voltage, then again go to insert and y label. You can click here and write, for example, this is current. You can add also some title here. Again, go to insert and see there are some titles here. Okay. So for example, if this is a VI, this is my VI cap, I can write the title here. In this way, you can create a very simple basic plot. Okay, clear. Now these are very simple things, and you can also change the way the plot looks from this insert table without using the code. You can just manually do these things. But using code here, you can also change how your plot looks. We'll go through these things a little bit later. So first, for example, say I want my plot to be, uh, it was blue color, right? This one is, the line is blue color. If I want to change the color of the line, if I want to change the width of the line, I can also change it from this plot of here. You see, if I write plot here, there are some options here. That is, this is y, this is the variable. Then you have line spec and options here. So if I write x comma y, then line spec, that is here, you can see it is saying here the line style, marker, color. So for example, I have to write it like this within the apostrophe. B means my uh, blue color. Okay, and O means that is the marker, and this space, this means the dash. Then I can change the width of the, you see now my width of the plot has changed. It previously by default it was 1, now it is a little bit more thicker. So because I have written here line width, comma 2. This means the width of the line, that is the width of the plot should be now 2. Okay. B means the color will be blue. As you can see, the color is blue here. Then 0. This is the type of the marker. You see, these are now circle type marker. Okay. Now if I give asterisk here, and then okay, you can just go to plot and see in the data, in the documentation, you can see these things are mentioned here. If you go to the very bottom of the documentation, see that is the worker, then the line spec here. You see the line style, marker and color. The line style, that is the solid line or dashed line. I've written this dash. That means the line will be now solid, single line. Okay, the solid line. If I write, see that now the line will be dashed. This is clearly said in your documentation. You see, if you within quotation, if you use this symbol, then it will be dash line. If you use the semicolon, it will be dotted line, just like here. Then if you use this one, then it will be dash dotted line. Then the marker, you have this marker. For example, for zero, for the circle, you have to write 0, then your plus sign, you have to write plus, then asterisk, then dot. All these things, if you just maintain it, you don't have to maintain the order here. Okay, you can even write it like this. MATLAB will understand. Okay, see, it still shows you the curve. Wait, because if I now write like this, you don't need to mention, you don't need to mention the serial. You don't need to maintain the serial here. Okay, if you just write blue, for example, if I now write here K, K means is for black. You see now the color has turned to black. So in this way, you can actually customize your plot. Then if I want to if I want to add some label, then I have to write X label. Then let's say it was voltage. So V. Then I can also change the font size. You see, within the first bracket, if I write font size, comma 12, let's say the font size is 11. Then similarly we can write Y label, and it should be current, and then again font size, let's say 11. And then for title, I have to write title here. Then if I write this is VI curve, and the font size, let's say 14. Okay, then you can actually also, now if I just run it, you see this curve is created. That is the VI curve, current and voltage here. So now see it is a little bit. You can also change it by double clicking here. Okay, from the plot, instead of writing here, you can actually change it here. For example, if I want to give a space here, I can just simply change it from the plot, from this figure window. Okay. Now you see there are no legend here. So you can also add legend from this insert here, or within the code you can write legend and IV. For example, IV curve I've written here. Okay. Then this location is important. Okay. So let's say I'm not giving the location first. So now, You see, it's not showing clearly. The location needs to be clear. Let me show you here again. Location. Oh, so if you don't give the location correctly, it will overlap with your plot. Okay, for example, see here, this one. When you are zooming in, see the legend is overlapping with the curve. So you can actually fix where it should be there. You can actually drag it here. Okay, you can also drag it in your plot window, but you can actually fix the uh, location in the code also. For example, if I write location, let's say, uh, see the options are here. So let's say north is outside. See, now it will be outside your window, outside your plot window. Okay. So, but if I just write northeast, now it will be inside your window here. Say, okay. So in this way, you can actually change the X label, Y label, the title or the legend and these things. So this was your basically the basic, very basics of your plot. I'm sure you already know these things by now. And again, this you can find a great deal of help in this documentation. There will be a lot of examples here from which you can actually change the way your plot looks. You can take help from this documentation. There are all the possible scenarios are mentioned here. You see all the how to change the color. You can also use this RGB triplet. You can also you can also actually customize the colors that you need. You don't have to be confined with it red, green, blue, and these things. You can actually also change by using the hexadecimal color code or actually or the RGB triplet. You can also change these markers here. Okay, you can also change the color of the marker. Okay, for example, you see there are marker indices. All these things you can actually take help from this documentation. You don't need to memorize any of these things. Okay, now let's say I want to create a uh, sign plot. So you know, this function line space, right? So what does line space do? Can anyone tell me? This line space. Anyone? So what does this thing will do? What should be the output of this x line space 0, comma 2 star pi, comma 100? What should be the output of this one? Anyone? What type of output should we expect from this one? Asoke or Ado?
Sir,
Yes, I can hear you.
sir, I can't remember.
Okay, so what it does is, let's see, if I run it here, it will create 100 equally spaced point, the lin space. Okay, so this is the range from 0 to 2 pi. You see, if I let me make it take a very simple example. Let's say I'm taking 10 points within 0 to 2. See, it will create 10 points with equally spaced. See, the difference between these two and the difference between these two will be same. Okay, let's say if I take it 9, you see 0, 0.25, then again 0.25, that is zero point 0.5. In this way, it will create 9 points there from starting from 0 and ending at 2. Okay. and it will create 9 points which have equally spaced points. Okay, the difference between the 2 points, any 2 points will be same. So now when I write x equals to linspace 0 to 2, 0 to 2 pi and 100, that means I want to observe a sine wave. Okay, here I want to observe a sine wave that starts from 0 to 2 pi. This is in radian. Okay, from 0 to 2 pi I want to observe this sine curve. Now let's say y1 equals to sine of x. Okay, these are the x-axis values and this is my y-axis value. That is, for each of the x values I'll get some y values and then we'll plot it. So now if I write plot x comma y1, see, I'll get this sine curve. See, it starts from 0. 2 pi means a value very close to 6, value a little bit more than 6, yeah, 6.28, right? So now here I get this sine wave here. Now let's say I want to create a cosine wave. So then let's say y2 is equals to cos x. Then if I plot x comma y2 and then click on run, you see here I'm seeing the my cos curve, right? The sine curve is not present here. The sine curve is lost here. You see, your cos curve should look something like this, right? So the cos starts from this point, right? Something like this. This should be your cos curve, right? In this way. But see, when I run this code here, this is a script file, normal script file. Uh, when I run this here, my sine curve is lost here. So what should I do? So one of the thing, can you guess? Like, do you know how to have both of this figure when I run this script file? Let's see if I save it. If I run this file .m file, I'm having all these values in the command window. But see, but I can only see this cos curve, but I cannot see this sine curve. So do you know how to observe both of the curve?
In the same plot function, we should also plot so x comma y1 comma x comma y2.
Yeah, actually you can also do that. But see, if I use a line here, that is if I write figure here, okay, then again, if I write figure here, it will create two figure window. See, this one is one of the figure window. See figure, this one is named figure 5. This contains this comes first, right? The sine wave here. So this figure 5 shows you the sine wave. Then comes your figure, next figure, that is the cosine plot. It is shown in figure 6. Okay. If you just simply write figure in front of the plot, a new figure window will be created for that plot. Okay. So as you can see in the example here, see figure 5 here and figure 6 here. Clear? Now, let's see if I want to plot both of these two in the same window. I want to plot both sine wave and the cos wave in the same window. What can I do? A simple, so you have said that if I just write both of these in the same window here, right? X comma y1, then x comma y2, like this, right? You
Yes.
see, writing like this will also help you plot the both of these sine and cosine wave in the same plot. But the thing is, you don't know when you will plot curves together. Okay, there can be several plots. You might, sometimes it may happen that you will add this plot, you will append this plot later. Okay, so you don't, maybe it's like that, you don't know beforehand. So what you can do is actually simply after this plot, just write hold on. If you write hold on, this will mean that okay, this plot is this one is plotted in your window, figure this figure, then it will not close this figure. Hold on means it will hold on the this plot here. It will not close that figure. It will not create a new figure. It will hold on and then create the same plot in the uh, create this plot in the same window. Now then, if you write hold off, then it will complete the plotting the values in the same plot. Okay. Now if I just run it, you see, I'll get the same thing here. Clear? Just using this hold on. Okay. Now see, if I plot something different, say again I want to plot y, let's say y3 is equals to cos x plus sine x, and plot x comma y3. You see, this one is plotted in the new window. Only this one is plotted. This one is lost because I didn't create a figure here. Now see, this is my last plot and this is a cos plus sine plot here. Okay. Now if I just remove this one here, you'll see that all the three plots will be formed in the same curve here. See, just by simply keeping this hold on, I can create all the plots in the same window. Clear? I hope there is no question. This is the very basic of plot. So do you guys have any question up to this? Anyone?
Okay.
Okay, very good. So we can actually change it like this. For example, if I want this to have the color red, then asterisk. You see, the sine wave is marked in asterisk and the cos is marked in this circle. Since I didn't choose how the line should be, if I want it to be solid line, I'll just simply give a dash here, hyphen here, and now these lines will be connected. Clear? Okay. So in your lab sheet, these things are given. You can also check it from your lab sheet that which points, for example, this one, the 6-star pointed hexagram, the marker type are given in a lab sheet. Okay, so this was our basic plot. That is, you give some x values, and for those corresponding to those x values, you plot the y values in your this x y x curve. Clear? Now you have this scatter plot. So what is this scatter plot? So do you know what this scatter plot is? So see, if I now write here, okay, so these things about this figure and these things are clear, right? So if these things are clear, I can just simply do the rest of the code in this live script, because I did this in the normal script.m file because I wanted to show you this how this figure works and this hold on, all these things work. Okay. So do you have any question for the about this figure and this hold on? So if not, I'll just continue it in the live script. Okay. So let's say I have the same thing here. X equals to, say, from 0, 1, 2, 3, 4. Okay, then I have y is equals to, let's say, 5, like this. Now if I write scatter x comma y, you see, now they are just plotting the points here. Okay. See, for example, this one is for 0, comma 4. You have this 0, 4, 1, comma 5. Now they are not connecting these points. Okay. They are just simply plotting the points in your graph. Okay. In a scattered way. Okay. They are not connected. They are not connect. The MATLAB is not, by default, it is not connecting these 2 points here. For example, from this point to this point, it is not connecting with a simple line here. Okay, so this is actually what helps is that as a scatter plot, it helps you to display continuous values. Okay, it shows the relationship of the points or the density of data points. For example, you see the density is high here. More points are in this region, that is 0 to 2 region. Okay, if I create more example, let's say, see, most of the points are in this region, and only 2 points are, yeah, far from these points. Okay, so the scatter plot, it will just show you. For example, if I show you these points here, you see from the left sheet, you see they are just pointing the plots. They are not connecting the plots or anything like this. Okay, so if I just let me show you the difference with line plot and this scatter plot. So now if I write plot x comma y and then scatter x comma y, you see, in line plot, it will connect this point serially. That means if this, it will connect this point with this point, then this point will be connected with this point. In this way, it will continue to connect serially. Okay. So for example, this one is what, 16 comma 11. Okay. That is 16 comma 11 is somewhere here. This one, 16 comma 11. Then 16 comma 11 will be connected with 6 comma 11. You see, 16 comma 11 is connected with 6 comma 11, then 6 comma 11 will be connected with 11 comma 22. So it is like somewhere here, see, 11 comma 22. So in this way it will go serially, sequentially it will go. These 2 points will be connected to this point will be connected to this point. In this way it will go. But you see, in scatter plot, none of these are connected. Okay, it will just simply plot the points in your graph. Clear? For example, see, if I take 1,000 points like this, you see, you can actually you can actually see the density of these points. Most of the points are centered around in this region, that is 0 comma 0. Okay, so randen, what is that? Do you know what randen is? What is randen? What is
Normal
rand?
distribution.
The normal distribution of numbers.
Exactly. So since normal distribution means what, it is a Gaussian, it will follow the Gaussian curve, right? It has mean, I think mean was 0, right? So see, most of the points are centered at 0 comma 0, around 0 comma 0. So when you see the histogram, you'll actually see that it follows the bell curve. Okay. So that this is actually the basic difference between scatter plot and normal line plot, is that these points will not be connected. Now comes the bar chart. So so let's say you have this values here. 30 is too much, let's say 10. Okay. Now if you just write bar of x, it will create a bar plot. Okay, so this index, this will be automatically assigned to your x-axis. Okay, the first one, it is having the value 16, 8, 5, 9, 2, 3. Okay, the first index, that is 16. So the x-axis will contain the index unless you mention it externally here. Okay, if you don't mention it explicitly here, it will uh, take the index x the x-axis value. Okay, and the y-axis value should be these values here. For example, if I have created some random integers from 16, 8, 5, 9, 2, 3, 19, 20, 12, and 2. So the first one is 16. The first one is 16. Then you have 8 here. Then there should be 5. Okay. So in this way, it will plot all these values as bars. Okay. And similarly, you can actually uh, change the colors also. If you write x comma r, this means the color will be red. If you write k, the color will be black. Okay. Uh, if you write same way, the way you customize your normal line plots, you can apply those things in these bar plots and other types of plots also. Okay, so these are universal. These customizations you can apply this for both scatter plot, line plot, and also you can use this for bar plot, your histogram, and all these things. Clear? Now let me take some example from the, for example, this one. You see, now you are explicitly mentioning this x value. If I run it, you see you have nine x values, that is from 1900 to 1980. So, and for each of these years, these are years 1900, 1910, 1920. Then for each of these years, you have some specific values. Okay, now if you write bar x comma y, see at the x axis, these x values instead of the index, now you have some explicit values of the x-axis. It is 1900, 1910, 1920, 1930 in this way. And for each of these values, the corresponding y values are plotted here. For example, for 1900 it was 75, 1910 it was 91. So see, for 1900 is 75. For 1930 it was 12. For 1930 it is 12. 1, 2, 3, 4. 1, 2, 3, 4. This one. Clear? These are very simple bar plot. Okay. Now, what if I plot, if this, let's say Z is a matrix, let's say magic 5. You have a 5 by 5 matrix here. Now, if I write bar Z, you see, let me write it 4 here. It will be much more easier to understand. 3. You see, a bar plot is created having the index value 1, 2, 3. So, can you guess what's happening here? If I click on this one, it is 1, comma 8. This is 1, comma 1. This is 1, comma 6. So, did you guys recognize what's happening here?
Is
It's
showing the
plotting the
different elements
columns
of
of
the
the
matrix.
matrix.
See, it is considering the index, that is each of the row as one index. This row, 816, this is index 1, see 1. And the y value is 816, see 816. And similarly, this plot, the second index, you see, it is the y value is corresponding to the third row, 357, see 357. So when you are plotting a matrix in as a bar plot, it will consider each of the rows as your index. Okay. So these are now plotted in separately. Okay. So for the first one is plotted here, the second one is plotted here, the third one is plotted here. You can actually plot it one over another. Okay. For example, you see these one are separately plotted here. The x-axis values 816. Okay. The first index, these bar plots are separated here, right? This one is 8, this one is 1, this one is 6. If you write z comma stacked here, see, now see, these one are now the each of the index are plotted over, they are overlapped over one another. See, this one is 8, this one is 8, then you have 1, then you have 6. Okay, this yellow portion, this corresponds to 6. Let me say 2, 2, 3, 2, 5, 6. 2, 8, 9, then 2, 11, 12. See, now it's clearly visible here. See, this one is what? The first, this bar plot, this bar represents your the first axis, the first row. It is 2 to 3. See, 2, then 2, then 3. Okay. Then this the last bar represents the last row. Clear? So the point is in bar plot, when you are trying to plot a matrix, the rows will be used as an index. Clear? Do you have any question? Okay. So now they are plotted as index. Now I can change the name of this index here. Okay. So let's say I have some categories. So there are 4 rows. So let's say there are 4 categories. So let me write categories is equals to, let's say it has to be some cell matrix, some cell array. That is A, let's say B. So these are the categories. For example, A means this first row. This first row is A, second row is B, third row is C, then D. Okay. Now I want to change this x-axis tick. That is the x-axis label. This tick one values instead of 1, 2, 3, I want A, B, C, D here. So what I can do is that let's say it should be set. It was GCA. Okay, GCA means C. Get current axis. Okay, get current axis or chart. This is my I'm working with this one, this bar plot. So GCA means it will get the axis of these plots. Okay, when you write set GCA, it means get current axis. That means the axis or the chart of this plot here. Then you can change the tick level. Okay, previously you used what? This X label and Y label. So X label and Y label is the name of this X axis or the Y axis. But if you want to change the tick here, that is here 1, 2, 3, 4, then here the Y axis values are 5, 10, 15, 20, 25. You have to use this GCA. That means GCA means what? See, get current axis or chart. That means the axis of this, the axis that is X axis and Y axis, the tick. If you want to change this, you have to use this GCA here. Then write GCA, then if you want to change the x-axis level, you have to write x. You see, it's not written here. X tick label. Okay, this x tick label here. That means you want to change this x tick values. Now I want to change this with categories. So I'll write simply write here categories. And now if I run this, see the x tick values have been changed. Clear? Any question on this one? That this GCA, this set GCA thing? That this you have to use this set GCA when you want to change this tick values here. The X tick values, the Y tick values. For example, if I write, I can do the same thing with Y axis. I'm just showing you this one just for understanding. See, if I write this, see A B C D again, it will start from A B C D A. Clear? So for example, if I write okay, whatever. So if you want to
So
change this, yeah,
why didn't you use X tick label and Y tick label?
I didn't get
What's
it.
the So why didn't you just use the X tick label command to change it
But
like
just
we
like
did
the
previously?
for like this. Okay, let me see if that works or not. In this way. In this way, you mean this way? Okay.
Yes, sir.
Yeah, this is also working. But there are some things that GCA is used. There are sometimes when you don't use the GCA, you cannot change some things. Okay. These are actually added later. A later version of the MATLAB, these things are now they have made these things much more easier. But in the previous versions, they you couldn't have done these things without GCA. Okay. So for the later version, they have made things much more easier. Clear? So
Yes, sir.
now, for example, now it's working here, but if you used MATLAB 2015 or previous version, it wouldn't have worked. Clear?
Yes, sir.
Okay. Okay, great observation. Now we have this histogram. I'm sure it was histogram. Yeah, histogram here. Okay. Now what happens in histogram? So histogram actually shows you the distribution. Yeah, histogram shows you the distribution of this numerical data. Okay. So that is, it shows you how the data is spread. So for example, there is diabetes.csv. So if I import this one, you see what your histogram is does is that it it creates some bins. Okay. So if I go to the documentation, so what it does is that see, I have this in this diabetes data set, I have this column age. Okay. There are lots of age, for the 50, 31 in this way. Whole range of ages are present here. Huh? So when I write is histogram, when I plot this age column as a histogram, what it does is that it creates some bins. Okay. These are each of this bar, each of these bars are bin. You see, bin. Okay, so value is 290. So what each of these bin represent is the number of values within this range. Okay, if I see, you see, it says bin age from 20 to 25. That means this bin, this is one bin here. Okay. You see here, you have some datas. Okay, let's say from 10 to 100, you have some values from 10 to 100. Okay, there are several. For example, there can be 10, 20, 33, 21, 55. In this way, there are a lot of values within this range, that is 10 to 100. Now when you use histogram, when you write, for example, this one is x, if within this x, when you write histogram X, what it does is that it creates some bins. Okay, by default, it creates some bins. You can actually change the number of bins. Okay, let's say it has 10 bins. Let's say for now, let's say it has 10 bins. That means it will create 10 basket like this. Okay, so for example, there will be 10 basket here. Each of these will have range. For example, this one is from 0 to 10. Okay, all the values here in this, all the values here in this data set, all the values that are within the range of 0 to 10, it will keep this in this bin. Then you have from 11 to 20. This one, let's say 1 to 10, 11 to 20. Then you have 21 to 30. In this way, it will create 10 bins. And the number of values, for example, 20. 20 is within which range? 20 is this range, right? So it will keep 20 here. Then 21. 21 is here. So there are two values here. 20. Yeah, let's say these are the only values. Say 67. 33, say 15, then 25. So 25 also falls within this range, 11 to 22. So there are three values that are within 11 to 22 and only one value that is within 1 to 10. So there is one. Then 15. 15 also falls in this region. So it will be 4. Okay. Then you have 33, 33. That is, it falls from this in this range, that is 31 to 40. So there are only two values, that is 31 to 40. So it will create some bins. For example, this bar plot. Okay, that is from 1 to 10, then 10 to 20, then 30, 40, in this way. So within 1 to 10 there is only one value, so it will create a bar plot that is having the value 1. Then within 11 to 20 it has four values, this 1, 2, 3, 4. So it will create another bar having the value 4. Okay, then within 21 to 30 there are no values here, so it will be 0 here. Then 31 to 40 it has only two values, so it will create another bar having the value 2. Is this clear? That means the x-axis here, the x-axis represents your the range of the data values. Okay, and the y-axis, histogram, you studied in your SSC level. That is, the x-axis contains the range and y-axis contains the frequency. These are the frequencies, right? This one. That means what? Only one value falls within this range, 0 to 1 to 10. Four values falls within the range 11 to 20. These are the frequencies, right? The same thing is happening here. So if I take a much more simpler example, let's say x equals 2, when let's say I want to have the maximum 30 and 1 comma, let's say I want to take 20 values here. Okay, so I have 20 values within range 0 to 30. Okay, now if I write histogram x, see, it is creating some bins. Let's say if I just take 10 values, let's say just 10 values, you see 3, 8, 25. You see this one, it has the range 0.5 to 1.5. So is the values within 0.5 to 1.5, there is only one value. See this one here. So its value is 1. Then this one, it is ranging from 2.5 to 3.5. Within 2.5 to 3.5, there is 3. These edges, this distribution, the number of bins, these are uniformly divided. Okay, the range is uniformly divided. That is 0.5 to 1.5. Then you have 1.5 to 2.5, then 2.5 to 3.5, in this way up to 27.5 to 28.5. Then you have 28.5 to 29.5, then up to 30, in this way. Clear? So you can actually uh, is in this example, see, you can actually change the bins, number of bins. Okay, so if I want to have, let's say, only 5 bins, I can write x comma 5. See, now there are only 5 bins, 1, 2, 3, 4, and 5. So the first bin is from 4 to 10. So within 4 to 10 there are only 7. Okay, so it has value 1. Then you have 10 to 16, 4 to 10, 10 to 16, this way up to 34. That is, these will be, there will be 5 bins with equal, how should I say, with equal range. Okay, see, the range is what, 4 to 10. It is 6. 10 to 16, 6. The width is what, 6. 6. The range is from 10 to 16. That is 6. The width of the range is what, 6. Similarly, from 28 to 34. Maximum is 30. So we don't need to go further than 34. Clear? Because if you divide 30 by 5, it should be 6. So the range is 6. Is this clear? The histogram plot, like how this histogram is formed. Any question on histogram? You see, 29 within 28 to 34, within this range, 28 to 34, how many values are there? 29 is there, then 30 is there, only two values. So the value is 2 here. Within 16 to 22, 16 to 22 is 1, 2, then this one also 3, 4. See, the value is 4. So did you understand how this histogram works? Any question on this one, on histogram? Okay. Now you can do some more types of customization in histogram, for example. For example, take a look at this code. You have two data ranges. Yes, some random 1 to 1,000 values having the following the Gaussian distribution, that is the normal distribution here. And again, we have another data following the same distribution. Now, if I want to plot these two, now phase alpha 0.5 means the opacity of this plots here. Okay, 0.5 means it is the opacity is 50%. Okay, if I like 0. Let's say 9, you see the opacity has increased. Clear? So see now, uh, I've previous in the very beginning of the class, I asked you what this rand function is. So you have told me that the rand function follows the normal distribution. So isn't it what the normal distribution looks like? Okay. The normal distribution looks like what? Like this, right? Like a bell curve, right? So the same thing you can actually see from this histogram. So if you want to overlay two histograms, you have to use this hold on function. Then to have better visibility, you can just simply change the opacity by using this phase alpha function. All these things you can find in your um, documentation. So is this clear up to this?
Sir, why did we use the hold off again?
It's redundant. You don't have to actually use it because it's a good practice to use hold off because for example, if I want to do some more codings and I don't want to overlay those types of, for example, if I want to, let's say I want to plot this one here. Okay. So it is not, let's say I want to, okay. It's a good practice because if you don't use the hold off, if and if you try to plot other things, what will happen is that it will overlay it in this picture again. Okay. So let's say,
Okay, okay.
see, can I see this now? So now you don't have some good visualization here. Clear?
Yes, yes, I see the problem.
Okay. So, but if you have used hold off, you see now these two will be now separated. Clear? Okay, then there is this legend. If you there are two data set, data one and data two. So using this legend, you can actually define which of this which color defines which data set. Okay. So if you use this legend here, data set one, then data set two, it will sequentially consider this data set one as the first histogram, data set two as the second histogram. Clear? Okay. Then there is another basic one is that your pie chart. Okay. Now there are some things about pie chart. Let's say I have some value 45, let's say. Here there is 25, 20, 10. I'm taking these values from lab sheet. Now if I write pi, values. You see, a pie chart will create it. So by default, it will show you the percentage, the values. Instead of directly the values, it will show you by default the percentage. You can change these things again um, in your from your documentation. You can see these things. Now, if I want to add the labels, so let's say A, B. Now see, if I write this label here, see this one is interfering with the pie chart. So if I just now initially I've told you that if I want to change the location, I have to use this location here, and I want to be outside this pie chart. So I have to select a location, for example, north, let's say northwest, outside. Oh, sorry. You see, now it will be outside here. So this one will look better. Okay, now the legend will not interfere with your original pie chart. Okay, so you have to use this outside, not this outside to keep the legend outside your pie chart. Okay, is this clear? Then you can do more types of customization with this uh, pie chart. For example, if I write values, comma, uh, if I want to, uh, let's say I want to focus on this one, this 45%. So what I should do is that, let's say Z is equals to 1 0 0 0. How many plots are there? 1 2 3 4. So this ones mean I'll give priority to this value 45 here. So now if I write values comma Z, you see this one is now getting the priority here. Okay. Similarly, for example, if I write 0 here and 1 here, you see this one is getting priority. Clear? So in this way, you can actually set the priority that which one to be zoomed out. Okay. This one is actually called explode. Okay. So you can also change here it is written that percentage here, that is 45%, 10%, 20%. You can also actually change the name of this here. So how you can do, for example, if I write regions, if I want to name the region. So there are four regions, let's say. Uh, again, similarly, uh, oh yeah, I can just write it like this. No, comma, labels. You see. Now instead of this values here, it will write the name of the regions here. Now I can just remove the legends. Instead of the legends, you can write it like this. Clear? So you can customize this pie chart, histogram, these things. All the customizations are available in the documentation. I'm just showing you a very little basic about these things. So up to this, any question about this pie chart, histogram? Okay, there is one more thing I forgot to mention is that, so the let me go back to the same data sheet, uh, the diabetes data sheet. So let's say you see there are some values 6, 1, 3, this pregnancies values. Okay. So if I want to show the pie chart of this column, so what should I do? What should I write? What should be the code? Can anyone tell me? I want to observe
Uh,
the pie chart of this column.
Pi diabetes dot
I
pregnancies.
diabetes
Okay. Pie.
colon 1.
Okay. Pie database dot. If I write pregnancies, it will be enough. Okay. Can you get a good idea about this? Can you get any information from this pie chart? Is there any information from it?
No,
Why is it happening? Can you guess? What's the problem with this thing here? This is the data set here,
So
the
there are
pregnancy data
too
set.
many data to plot.
See, exactly. So each of the when you are plotting this pie chart, he's trying to plot each of these value. So how many values are there? I write new male diabetes dot 768 values are there in total. Okay. So what it is doing is that it is trying to plot all these 768 values. Each of this pie, each of this section is one value. For example, 6. It is plotting 6 in one section, 1 in another section. It is creating 768 sections for this, all the 768 values. Clear? So it's not a good way to perform this, right? Similarly, if I go to this outcome, see, if you just look at this outcome, it will be much more clear. See, outcome here. Instead of pregnancy, if I write outcome. Okay, but so there are 768 values, but let's see how many unique values are there. Unique. There are total 17 unique values, right? Just 17 unique values, but it is plotting how many values? 768 values here, right? But I don't know, need these values here. I want to show how many, for example, 0. How many times 0 is appearing here? How many times 1 is appearing here? How many times 17 is appearing here? Right? That type of information we want to get from pie chart, right? Isn't it what we want from pie chart? We want from pie chart, what do we want to see? For example, see in this one, we are seeing that A is 45% of the time is A. D is 10% is D. That means D is occurring 10 times. A is occurring 45 times. B is occurring 25 times. In this way, right? So there are 17 unique values. So we want to show that how many times each of these values are appearing, right? So there is a function called categorical. Okay, there is this function called category. Oh, sorry. I think I need to change my keyboard. Okay. So what categorical does is that, for example, if I write y equals to categorical, say array that contains values assigned to categories. So what it will do is that if I write diabetes dot pregnancies, it will convert this into a categorical data. So what categorical data now? If I want write by y, you see, when you convert it to a categorical data, that means what categorical does is that it changes this column into a categorical data type. So what is the meaning of this categorical data type? That means now instead of considering them each of these values as individual, it will consider them as categories. For example, 6 is one category, 8 is one of the category, 1 is one category, 0 is one category, 5 is one category. Clear? So now see, now if you just um, zoom out this one, see, now it is somehow clearly visible, right? That is, see, 1 is occurring 18% of the time, 2 is occurring 13% of the time, 0 is occurring 14% of the time, right? Now you can get some clear idea about this, right? This is clear. So instead of pregnancy, if I write outcome, see, outcome contains see, there are 768 entries here, right? But their outcome is contains only two types of variable, either 0 or 1. So now if I convert it to a categorical data type and see it as a pie chart, you see 1 is occurring 35% of the time and 0 is occurring 65% of the time. Clear? this categorical thing on pie chart. Any question on this one? বুঝছো সবাই নাকি? Okay. Okay, then you have this box plot. Okay, so what is box plot? So as it's written here, it is used to show the distribution. Okay, highlight the spread, median, and the outlier. So consider this one. You have some data. Okay, for example, if I consider this glucose, this glucose values, or the let's say this blood pressure value. Okay, so what are the blood pressure of each of this individual? There are 768 individual and their blood pressure data is shown here. So someone is having 72, someone is having 66, 64, 67, then there is 0. So is this a normal value? This is not a normal value, right? These are called outliers. What is outliers? So let's say I am talking about the ages of some university students. Okay, so it falls within the range of, let's say, 21 to 24. Okay, people should be having, let's say, 21, someone's age is 21, someone is 22, again 21, 23, 24, 21, 20. Let's say someone is 19, then 25, 26. But if there is another way who is having the age 40, he's a third year student having age 40. So this is an anomaly, right? It doesn't fall in the normal category, right? That the normal range is what? Within 21 to uh 20, let's say 25. This is the usual range, right? Most of the students are falls within this age range, but it is very rare to see someone having with a age of 40 studying in the university, or it can be, let's say, someone with the age of 13 is studying in the university. So these are what? These are not normal, right? These are actually called outliers. Okay, some anomaly type value. Clear? These outliers. These are called outliers. This is outliers. Clear? Then most of the values fall within this range. So let's say 24, 23 is your median value. Okay. Mean, median, modes. So 23 is your median value. Now see, what box plot shows is that it shows a plot like this. Okay. This is a box plot. Okay. So you see the meanings are written here. So it has some region. So this is your interquartile range. This one is called interquartile range. So what interquartile range is does is that there are some see Q1. The range is from Q1 to Q3. So Q1 means 25 percentile and Q3 is 75 percentile. That means the values which falls within so as I've told you, the age range. Okay, so say most of the students are from this range, right? So let's say 25% of the students are, let's say, age is 22 and 75% of the students age is 24, let's say. So what will happen? The students having the age between this 22 and 24 will be plotted within this region. Okay, this is the region. This region will contain from 25 percentile to 75% of the data will be plotted within this region. Clear? So this is a box plot. Okay, so in this box plot, there are some Q1, Q3. Q1 means the quartile one. It is a 25% of the data that fall within 25 to 75%. Those data will be plotted in this box. Okay. Then you have this median head, this yellow mark, this this line. This is your median. This will show that what is the median of the uh, data. Clear? Then you have uh, these two bars here. These are called the minimum bar and the maximum bar. That means from Q1, that means from this point, that is the points that falls within 1.5 of 25% to 25%. The values that falls within this region, that has between 1.5 of IQR. IQR means this median, this interquartile from IQR to Q1, this region. Okay. So the values that points below 25%, but above this 1.5 IQR will be plotted in this region, and that the values that falls between Q3, that is the 75% to 1.5 into IQR, will be plotted in this one. For example, you see some values will be plotted. Say, let's say these are the values that are plotted. That means 70. Okay, and here it is, let's say 25. The values that are between 40 to 75, say let's say this is 68. The values that are plotted between 40 to falls between 40 to 68 will be plotted in these points. Okay, and the values that falls between, let's say this is 28, from 28 to 25 will be plotted in this line. Okay, and then you have this, most of the points will be in this box, and it shows you the median, that is the median is 30. Clear? Then you have some plots, some points that are bit ridiculous. Okay, that means these are not within the normal range, so these are the outliers, and the outliers fall outside of this minimum and maximum range. Clear? These are actually called whiskers. Whiskers. And the points beyond the whiskers are called outliers. So box plot, the terminologies of box plots. Did you guys understand this one? Any question on this box plot, this IQR, median, then outliers, then whiskers? Do you have any question on this one? So now see, if I want to find the box plot of uh, so do you guys have any question up to this? You see, the age after 60, for example, after let's say 65, this 60 to 100, these are outliers, because these are not regular values. This does not represent your data. Okay, these are some outliers here. Most of the ages are between your 20, let's say 25 to 40. This is the common range. Clear? So this common range is shown here, and this median is this 30. Okay, the median is 30, and then you have this outliers. There are few outliers, 1, 2, 3, 4, 5, 6. Some outliers that is having the values that are greater than 60 or 70. Clear? For example, this is outlier age. Sorry, that's the age. Yeah. See, most of the values fall within this 31, 31, 32, 27, 50. Okay. So do you have any question up to this? Anyone?
So,
Hmm. Yes. Uh, Okay, for example, is 66. It is a very uncommon value. Most of the range is between C 27, 28, 45, 22, 26, 21. Then there is a little bit high 52, then 66, 63. These are 66 is outlier. Clear? Because this falls above the normal range. Clear?
yes, sir.
Okay. Now, these were some very basics of plotting. Okay. Now I've shown you how to plot two plots in the same window and all these things, right? Now there is another thing called subplot. Okay, so it is in your part C. You see, let me do this again. You have this sine function here. Let's say I have another plot, say x equals to, so and these are three plots. Okay. Uh, Let me get another one. Which one should it be? So what your subplot does is that it can plot multiple plots in a single multiple plots in a single figure window. Okay, so instead of overlapping, you're still plotting it the same window, but you're not overlapping it. Okay, so this one is one. This is one same figure. So if I do this one, so now if I write subplot, uh, okay, now I want to plot these two, this cos and sine in the same window. Okay, so what I can do is this: I can use this subplot, then 2 comma 1 comma 1. This subplot, it actually represents a grid. Okay, so for example, like this, I have this window. Let's say this is a window, and let's say it has four grids. Okay, so there are total four right here. So that means this one is 1 comma 1, this one is 1 comma 2, 1 comma 2 comma 1, 2 comma 2. Yeah, this is what actually this means. 2 comma 1 means it will create two rows and one column. Sorry, when I write 2 comma 1, it will create two rows and one column. That means there should be this value. This represents the number of rows, this represents the number of columns. So 2 1 means it will create two rows here and then one column. This is one single column. So one plot will be plotted here and the other one will be plotted here. If I've written subplot, let's say 3 comma 2, then it would, what it would have done is that it would have created three rows, one two three rows and two columns. Okay, then this is first column, this is second column. Okay, so one of the plot would have been plotted here, the other one here. In this way you can plot six plots in a single window. Clear? So, and each of these windows are labeled as, this one is 1, this one is 2, then 1 2, similarly 1 2 3 4 5 6, in this way. Clear? So when I write subplot 2 comma 1, that means it will create two rows, one column, and this one will be, is that the when I'm plotting this one, this plot x comma y1, this cosine, it will be plotted in the first row, that is the first box here. That means on this one. Okay, on this one it will be plotted. So this one represent that how should I say, the first box, that is the first window of that figure window. Now let's say I have given the title, that is uh, sine wave. Okay, then again subplot. Now same thing, but now I will use it as 2. That is which, that is the second space. Okay, now I'll write plot x comma 2 That means this value will be plotted in the second space. This one will be plotted in the first space. I've created two rows and one column. So now let's say I give the title cost wave. Now if I run, you see this is a single figure window, and in the first space the sine wave is plotted, in the second space the cos wave is plotted. Clear? I could have done the same thing here. See, instead I, for example, I want to include this one also. So how many rows do I need? I want to plot this sine wave, this cos wave, and this also this z plot. So how many rows do I need here? How many rows do I need? Anyone? If I want to plot like this, one after one. If I want to plot vertically, that is one after one vertically. How many rows do I need? Hello, no one is here. I'm just taking the class with here.
One.
Three, right? See, if I write three comma one comma, what should be the value here? See here, what I am doing, I'm trying to plot three plots here, three figures here. This is one. This is the first one. This is the sine wave. Then you have this cos wave. Then you have this, that z plot. Okay. So there are three plots that I want to plot in the same window. So as you can see, for example, for this one, we have plotted sine wave and cos wave in the same window. So we wrote what? What did we wrote here? This one, right? 2 comma 1. This, what does this 2 comma 1 means? That means it has created two rows. This is one row, the second row. This is only one column. I've written here the first row, the first column. This one, right? But now I want to plot three plots in like this way. This should be one plot, this should be another plot, and this should be the third plot. So what should be, first of all, what should I write here? Subplot. What should be the code here? Subplot, what should I write here? I
Three,
want three,
uh,
then
313.
3, 1, right? First I have to set this, that is I want to plot three values here. So that's why 3, 1. 3, 1 means what? This is the first one, three rows, right? There is three, one, two, three rows, and there is only one column, right? Now I want to plot this one. So what should be here?
One.
1, right? Then I want to plot this one. So I have to write subplot 3 comma 1 comma 2, right? So the same thing here. So I've used 3 comma 1 comma 1 to plot this side, 3 comma 1 comma 2 to plot this cos, then to plot z. What should be here? 3 comma 1 comma 3, right?
Three.
The third one, see? On the third plot, we have plotted this z plot curve. Clear?
Yes, sir.
Now let's say instead of plotting like this, I want to plot it like this. This should be one, this should be another, and this should be the third one. What change should I do here in this one? So subplot
1, 3,
3
1.
comma,
1, 3, 1.
exactly, it should become 1 3 1 3 1 3, right? So see 1, if I write 3 here, see now they are plotted horizontally. Clear?
Yes, sir.
Okay. So if you want to do this, what should be the uh, subplot? What should be the values inside the subplot? If you want
2,
to
2.
exactly 2 2. Clear? Okay, very good. So this was your subplot. You can actually plot these curves in this way also. Okay, in this way you can actually plot your several plots in one single window. Actually, these things are done very frequently when you are writing some papers and these things. You have to compare several figures. You actually plot it in like this. You don't actually usually individually plot this, but you usually use the subplot to plot all the figures in one window. Clear? Any question up to this?
Gotcha.
Okay, I think the part one is over. Okay, now I'll go a little bit. I'll go through this 3D plot a little bit. So 3D plot. Okay. So there are several types of 3D plots there. So up to now you have seen 2D plots. So how many variables required in 2D plots? Just two variables, right? X and Y. Now in 3D plot there is another additional variable, that is another additional axis, that is the Z axis. Okay. So all this time you have studied this 2D plot, that means you needed an y-axis value, this x-axis and this y-axis values, right? But when you are trying to plot this 2D, 3D, what happens? There is a new axis. You have to consider this new axis, that is z-axis. Okay. So this 3D line plot is similar to your 2D line plot. That is in your 2D line plot, what happened? You had some x values and you had some y values, then x values, y values, you plot this point, then x values, y values, you got another point. In this way, you had several points, and these points were joined, right? By a straight line. You join these points here, right? The same thing happens in your 3D line plot. What happens? Now you have, instead of two values, for example, you have 3, comma 1, comma 2, let's say. So this is your x value, y value, z value. So x is 3. So 1, 2, 3. Then y is 1. So you had 1, 2, 3. Then z is 1, 2, 3. So in this way, so first you need to go x direction, that is 3 points. So 1, 2, 3. Then y 1. So this is 1. Then in the z direction you need to go how many points? 2 points. This is 2. So 1, let's say 1. This is 2. So what happens is that this is your 1 point. That is 3 comma 1 comma 2. Okay. So this set x. This is, let's say, 3 comma 1 comma 2 in this 3D space. Then you had, let's say, another point. Let's say um, let's say 4 comma 3 comma 2. So that means you need to go 4 points here. 4, then 3, 1, 2, 3. Then and along z axis you need to move 2. So let's say this one is the point. So so what your MATLAB does is that in the 3D space it will connect these 2 points. Okay. So for example, let's see. If I write here x equals to, say, same thing, 1, 2, 3. I'm taking just 3 points, and y is equals to, let's say, 4, 5, 8. Z equals to, let's say, 9, 2, 1. Okay. Now, if you write plot 3, 3 means, you see, when I write plot, if you write simply plot, it will be 2D line plot. If you write plot 3, it will be 3D line or 3D point or line plot, 3D line plot. So plot 3, now you have to provide the x, y, and z values. So x, y, z. Now if you run, okay, so I need to, okay, see, another thing about this subplot, it will continue to append when you create another plot. Yes, so let me remove this one. You see, You see, now you have this, let's say if the customization will be again same. Let's say X label. Let's say this is X. You see, now you have this X axis, this Y axis, and this Z axis. Now say if you click on this point, this is C. X value is 252. This is in the 3D domain. You can rotate it here by clicking it in this one. You can rotate and see in the 3D domain. You can actually plot the points, and it will sequentially connect these 2 points using some straight lines. Clear? Similar to your normal line plot, but it is in 3D domain, having an extra axis, that is Z axis. Now the Z value also matters. Clear? So similarly, if I plot this one, see, now I have three values here, sine, cos, and t is Z t value. You can create a helical structure here. Clear? This 3D line plot similar to your 2D line plot, but now you have some extra Z axis value. Now comes this surface plot. Now the surface plot, you need to understand something. Okay, if you just write uh, here instead of okay, before going to surface plot, another thing is that scatter plot. It is again same as your 2D scatter plot, but now only the points will be plotted in your 3D domain. Okay, you see it, and they will not be connected. Just same as your scatter plot in your 2D domain. Now in the 3D domain, it will be plotted. It will now have three values. These z-axis values will also matter now, but these things will not be connected. Clear? This 3D line plot and 3D scatter plot. Do you have any question on this one, in these two? They are similar to your 2D one, but just now they are being plotted in your 3D, three-dimensional domain. So do you have any question up to this? And 3D line plot and 3D scatter plot. I have plot. They are simple things. Now comes this surface plot. Now see, if I write, let's say, okay, if I write surf x, y, z, you see, z must be a matrix, not a scalar value. Okay. So your surface plot, it demands that your z should be a matrix. It cannot be a scalar vector, because why? See, what your surface plot demands is that for each of these combination of x and z, x and y values, for example, you have what? Here you see you have uh, x equals to what? 1, comma 2, comma 3. Then y equals to you have 4, comma 5, comma 8. Right. So you actually form a grid with these values x and y. Okay. So if this is x, this is y, you have to form a grid with these x and y values. So x is, let's say, 1, 2, 3, 4, 5, 8. So you have to form this grid. So for each of these x values, you need to consider all these y values. So x equals to for 1, you had y equals to for this point, then x equals to 1, this 1, 2, 3. Let's say this is 4, 5, and this is 8. Let's say. So 1, comma, this should be 1 point, then this should be another point, 1, comma 5, then this should be another point, 1, comma 8. In this way, you have to form a grid. Okay, so here total 9 points are there. And now for each of these 9 points, we need to have a corresponding Z value. Okay, so for example, these values, for each of these values, you need to get a Z value. Let's say this is for this, we have Z is equals to, let's say 2. Okay, that means this is 2, Z equals to 2. Then this, let's say this is Z equals to 3. For these 3 points, you have z equals to 3. Then again, for this point, let's say you have z equals to 5. Okay. So now what your surface plot will do is that it will join these points and these points and create a surface along this with this 9 points. You see, you have x equals to these things. Now let's say z is equals to, you have to create some mesh first. Let's say x, y is equals to mesh grid. What mesh grid is there is that, you see, when I write x comma y mesh grid, see, it creates this x. See, x is to 1 to 3, y is to 4, 5, 8. And this capital X and capital Y. See, a mesh has been created. See, this x is to 1 to 3 is repeated. 1, 2, 3, 1, 2, 3, 1, 2, 3. And then y is 4, 5, 8, 4, 5, 8, 4, 5, 8. In this way, they are now repeated. So what your surface plot will do now is that if you write surf x, sorry, x comma y, it will create a combination for all these points. That is 1 comma 4, 1 comma 5 in this way. Clear? Wait a minute. Just wait 1 minute. I'm coming. Okay, are you guys here? Okay, see, when I've written x, y into mesh grid, see, x is repeated 1, 2, 3 along the row. Along row, the x values are repeated. That is 1, 2, 3, 1, 2, 3, 1, 2, 3. And see, y values are repeated along the column 4, 5, 8, 4, 5, 8, 4, 5, 8. So when you write, when you have written surf x comma y, what it will do is that it will create points from this x and y values. That means for 1 comma 4 should be one value here. Then you have 1 comma 1 comma 5, 1 comma 8. Okay, in this way it will create total how many values? 3 into 3, 9 values. That is 1 comma 4, 1 comma 5, 1 comma 8, 2 comma 4, 2 comma 5, 2 comma 8, then 3 comma 4, 3 comma 5, 3 comma 8. In this way it will create uh, 19 sorry 9 values. So now if I write, say if I write z equals to, let's say 1 is to 9. I've created 9 z values here. Now if I write x comma y comma z, or it should be a matrix. Say 1, 2, 3, 4, something like this. Now see, this surface is created using the points. This is clear. Now if I take a good example, for example, this one. Not this one, let's say x equals to 4, 5, 6, 7, and your y is, let's say, 9, 1, 20, 8. Okay, can you see this now? See, what it did is that if I write instead of this one here, hmm. Now see, it has created along the x-axis and y-axis, you have the value C 1, comma 1, 1, comma 2, 1, comma 3, 1, comma 4, see 1, comma 1. See 1, comma 1 has the values 2. Then yes, 2, comma 1. See 2, comma 1. Then 3, comma 1. Then 3, comma. All these are having the same Z values. Why? Because see, uh, see Z for 1, comma, see 1, comma 1, 2, comma 1, 3, comma 1, 4, comma 1, 5, comma 1 is corresponding to this row. Clear? These two values 1, comma 1, 2, comma 1, 3, comma 1, 4, comma 1, 5, comma 1 is corresponding to these values. Then again, this 1, 2, 3, 4, and this y values 2. This 1, comma 2, 2, comma 2, 3, comma 2, 3, comma is corresponding to these three values here. Value 3, then value 4. In this way, see, this one is 1, comma 1, comma 2, this is C. 1, comma 2, comma 3. That means 1, comma 2, this value. Then 1, comma 3, comma 4. In this way, all these values are having the same Z value, that is the same height. And then what your MATLAB did is that it has joined this, connected these points, and then created a surface from this line. So this surface plot, is this clear? That means using the mesh grid, I have created a mesh grid, a grid of the value with values X and Y. And for each of these values, I have some specific Z values, that is some specific height. Clear? And then I have plotted this and a surface is created. Now this is just for understanding. Now if you write this code here, you'll find this surface as here. For example, I've written sine is square root of x squared plus y, sine root over x squared plus y squared. That means this one. So when you plot this sine curve here and in y-axis, you'll find this uh,
Okay.
3D surface here. Clear?
Yes, sir.
The main thing is that your Z, it needs to be a matrix. You cannot find this curve using a vector. Clear?
Yes, sir.
And the mesh plot, it is the same as this surface plot, just it is shown here a little bit differently. This was solid, now it is shown in a mesh form. Okay, so there is no difference between surface and plot, the surface and mesh plot, other than the look of the plot. Okay, now you have this contour plot. Now the plot is also same as this your surface plot, but here you see in the contour plot you don't have this z-axis. Can you see any z-axis here?
Sir.
There is only x-axis and y-axis. But what is this z value? Let's see. You see, I still have this x and y mesh grid. Then I have some z value. See, z is a matrix now. Now I have plotted contour x comma y comma z. Now I found this one here. Now here, instead of some z axis, the z is shown using this circle, this contour. These are some surface, this contour surface. So just like previously, when you use this surface plot, we had some z value for each of the x and y values, right? Some specific z axis. Uh, Oh, nice. It should be good. Anyway, okay. The same thing. Okay. Let me show you the same thing here. This one is Z, this one is X. Then you have this surf X comma 3. You see here. This is the X and Y values. Yeah. And this is the Z axis. This one is Z axis, this is X and Y axis. And see, for each of these values, see, when I've created a mesh grid, I've created this grid of X and Y values. And for each of these points, okay, for each of these points, there is some certain Z values, right? For example, at this one, at the see, there are some height of Z. There are some values of Z, right? See, Z is 1 at this point. When X, there are some values of X and Y. At X equals to, let's say, 1, 0, comma 0, you have these values of Z as 1, right? So for each of these X, and if you just slice it, okay, see, if I just slice it like this, see, when I flatten it, can you see, this is the maximum Z value, that is 1. And these are low Z values, right? So when you flatten this, that portion is actually, that is actually this contour plot. See, same thing. Can you understand this one? When you flatten this surface plot, basically when you flatten this surface plot, you get this contour plot, and these contours are actually saying this. See, within this Z value, see, within whatever the, for example, this one is Z is equals to 1. So whatever the points having this value Z will be plotted in this one. For example, if you consider this range here, okay, wait, let me show you here. So for example, you have this uh, measure it. For example, for when x equals to 0, comma 0, you have z is equals to 1 for x, and around these points, for example, z is having this, let's say, this cylinder here, z is having this value 2. So whatever, for example, this one is 1 1, this one is 1 comma 2, this one is 1 comma 3, this comma is 1 comma 4. Okay, let's say, so all these values 1 comma 1, 1 comma 2, 1 comma 3, 1 comma 4, this x and y values are having the value z. So in your contour plot, what will happen, it will create a circle here, a contour here, which represents z equals to 2. And whatever the value of x and y that represents this z value should be plotted in this point. That means 1 comma 4 will be here, 1 comma 1 will be here, 1 comma 2 will be here, 1 comma 3 will be here. Clear? That means when we flatten this surface plot, we actually get this contour plot. See? For example, see, z is 0 comma 9.3. So within this value, say x is 0 comma 1 comma 2. If I take another value within this contour, uh, see, same z value, but different xy value. If I take another point, see, same z values, 93941393941, but different x value, x 0.25, comma 0, x 0, comma 0, comma 1, 0.25, minus 0.25, comma 0. Is this clear? That means the contour plots actually represents the height of z. Whichever values of x and y represents that height will be plotted inside that curve, inside that z value. So each of this circle is actually your z values. Clear? Just simply, if you think of like this is your surface plot. If you just look it from above, If you just look it from above, this is your contour plot. This is one circle, this is another circle, this is another circle, this is another circle. Clear? Any question?
No, sir.
আসে না কেন? So this is one this is one contour, this is one contour. See the yellow portion, then this green marks, this is another contour, this is one another z values, this is another z value. Okay, so I hope this contour and surface plot is clear. So this is actually the basics of a 3D plot that you need to know a little bit. Then you can actually customize this 3D plot same as before. You can just look at the uh, your documentation to observe this, how you can customize. For example, you can actually change the how the surface looks like. There are different types. You can change the shading of the light. You can actually change the color type. So for example, it starts from green and the lower value is blue. And in this one, you see the upper value is yellow, the lower value is blue. This one is yellow, blue. You can actually change these things. You can actually, if you look at the documentation, you can easily customize this 3D plots. Now then the last portion of this lab is that this geographical plot. Okay, so can you guys just give me 2 minutes? I'm coming. I need to run an errand. Just within 2 minutes, I'm coming. Okay, I'm back. Okay, now the next thing is your geography bro. Can you see this lab sheet here?
Yes, sir.
Okay, so one honest thing is that actually these lab sheets are pretty well built. So if you just guys go through the lab sheet, you'll have very good idea about this 3D plots. There is actually no need to show you all these things by taking a class, but still, since we need to take a class, we have to go through this. Now see your geographical plot, it is actually same thing as your normal plot, okay? But here instead of plotting in a blank space, right now we are by this time we have plotted in some blank space in a some white space, we have plotted some points, right? In geographical plot, what happens is that you actually plot points in your uh, map, in actual map. Your MATLAB can actually, when you use this geoscatter, geoplot, okay, when you use this geo, you see same scatter plot, same just normal plot, normal scatter plot. Okay, but when you use geoscatter, it actually will plot your points on the actual map. And now here you cannot plot random values. You need to plot the latitude and the longitude values. Okay, for example, if you look at this geoscatter plot, you have this latitude and longitude values. Okay, so let me copy this one and see. So when you plot this one, okay. So see, there are some latitude values. Latitude, so your map have some latitude and longitudinal values, right? When you see the global map at the globe, there are some latitude and you guys know what latitude and longitudes are, right?
Yes, sir.
Okay, very good. So you see, why is it written like this? Surface plot. So see, now we can visualize spatial data. For you have this longitudinal, latitude and longitudinal values. That means 23.8 degree latitude, then 90 degree at the longitudinal value. You see, when you plot this value, you find the city. That is, there are three cities. This one is for Dhaka. It represents, say, latitude value is 23.8, longitude is 90.1. Then you have this Chittagong here, that is 22.91. So when you use geoscatter, just similar to your scatter points, now you provide the longitude and latitude values, and now it will just simply plot the points in your map when you have this latitude and longitudinal values. But instead of geoscatter, if you use geo plot, it is a list of latitude and longitude. Uh, Oh, sorry. Okay, so see, now in the when you use geoplot, it will just connect these 2 points, same as normal plot. Now just in the map. So this is your 23, this is your latitude and longitudinal value of Dhaka, and this is your latitude and longitudinal value of Chittagong. So now it is just simply connecting. It is showing you a route from Dhaka to Chittagong. Now you can actually do one thing, that is geo base map. You see now the map, it doesn't look it's a grayish map. It doesn't, it isn't, you cannot clearly see the map. So if you just use geo map, this will actually help you. For example, when you go to Google Map, you can change the terrains, right? Similarly, to change the terrains, that is how the map will look like. You can actually use the geobase map. Now you will again same thing. You'll find these things in your uh, documentation. Okay. So if I just zoom out, you can actually change this to, instead of land cover, you can change this to streets. Okay. So now the street view, now the streets are shown here, these lines here. See, so you can actually change the terrains of the map using this geobase map here. Okay. Now you see, let me import one world cities here. I have this. Have this world cities data set. Now what I can do is that uh, so there are the name of these cities. You see there are the latitude and longitudinal values for all the cities here. Okay. Then this, I don't need the rest of the things. So now what I can do is plot all the cities in this map, geoscatter. If I use world cities dot lat comma world cities dot longitude is LNG. Okay. Now see, these are not clearly visible. So if I just change the type of the marker to point, you see, these are showing all the cities of the world that are within these regions. Okay. So in this way, you can actually see the type of we can actually plot the points then using the latitude and longitudinal values in using the map. Okay. Now we have shown you the geo plots. Okay, the last thing is that so so do you have any question for this from geo scatter or geo map? Do you have any question from this geoplot, geodensity? There are some more geoplots. If you just go through them, you can easily understand these things. So up to this, do you have any question? So geoplot and geoscatter is nothing but it is a simple your plot and scatter plot. Just here you instead of x random x and y values, you use the latitude and longitudinal values and you plot it in on the actual map here. Okay. So up to this, any question? Okay, the last thing is to create some animation. So let me load another data. So using this geoplot and geoscatter, the main reason for me to showing this geoplot and geoscatter is to actually form this GIF. There is a whole debate on the pronunciation of GIF, whether it is GIF or GIF. What do you guys call this?
GIF.
GIF,
GIF.
Give.
GIF. Okay. To be honest, I don't know what is the actual pronunciation. Anyway, so let me just explain you this code a little bit, and then I think we'll be done for this class. Okay, see now. I have some see this is actually I'm trying to make a GIF about uh the police killings, okay, over the years. The police killing over the years in some cities of the USA. Okay. So the city values, okay, the latitude and the minimum and maximum latitude. Okay. So if you see here, okay. So I want to observe the I have some data, this police killing data, this where is it? See. I have some data here. There are some IDs, the dates. Okay. There are dates here. Then the threat type. Okay. Then the cities. Yeah. We have this cities data here. Okay. And then we have this date at which date the police killing occurred. Okay. Then we have the latitude and longitude values of these cities. Okay, so there are a lot of cities, but for now we'll be focusing on a specific region. That is from this latitude to this latitude and from this longitude to this longitude. We are just focusing over a several region. For example, it is mentioned here from Florida to Florida, Minnesota, California, and Maine from within these points. Okay, within these regions, I want to see over the years how the police killing happened with whether it is increased or decreased. Okay, so I have this date here. You see this on 2015. Then I have uh this very long data, 2016 data, then 2017 data, 2018 data, 2019, and up to 2024, from 2015 to 2024. Okay, so I want to observe the police killing from over these few years. So that's why first I have divided the regions. Okay, so I am using this filter. Why? See, data. Your data is what? This one, fatal police killing. Okay, I've written this data is our fatal police killing, and oh wait. Uh, it should not be data. Hmm.
Answer, sir.
Okay, now I have loaded this police killing data into this variable data. Now, as I've told you that I want to observe from only from this to this. Okay, so that's why I have created a filter, that is you see data dot latitude greater than or equals to latitude minimum and greater than or equals to latitude maximum. That means you see the latitude and longitude values are here. So I am just treating saying that if the latitude values is greater than this one, consider those latitude values. If the latitude value is less than this one, like within these two regions. Okay. Did anyone say anything? Eh, okay. Then similarly, I have this maximum longitude and latitude values here. So I've just created a filter and then I have created df equals to data in USA. That means this one, the the logical array, the filter that I have created. So I've just taken those values with the values that are falling within this region. See, if I run this one, see our original table had 10,000 data, but now we have 8,900 data. Okay, so we have excluded the regions that doesn't fall within these few cities. Okay, now the process to create a GIF is that first you have to give a file name. Okay, so policekilling.gif. Then I have to observe within from 2015 to 2022. So now can you guess what should I do? You have by this time you have understood how to plot the GIF. Sorry, how to plot the geoscatter. You have you told me that you understood this geoplot and geoscatter. So first of all, which one should we use? Geoplot or geoscatter? First of all, which one should I use? I want to observe the police killing from 2015 to 2024. So that means for each year, I have to see that on which states the police killing occurred. Okay, so which plot should I use? Anyone? Are you guys even doing the class?
Geoplot.
Geoplot.
Geoplot,
Why geoplot?
latitude and longitude data.
আন্দাজে নাকি?
Scatter.
Because we want to connect the lines.
Why do we want to connect the lines? See, I want to plot this. That means only I want to see where the police killing occurred. I just want to see the density. See this point. I just
Oh, scatter.
exactly scatter. I just need to locate the areas where the police killing occurs. There is no point in connecting the points, right? So I will use geoscatter now. So I have these data here. Uh, I have this data. I have the longitude and latitude value over the years 2015. How many where the police killing occurred, the latitude and longitude value for 2015. I have those data. 2016. I have again. I have the same data for 2016, 17, 18, and up to 24. That means for each year, wherever the police killing occurred, I have those latitude and longitude point. Right. So what I will do is now is that for each year, I will create a geoscatter plot. Right. Did you get it? For each year, I will create a geoscatter plot. For 2015, I'll create a geoscatter plot which will show me that, okay, at these points, at these places, the police killing occurred, right? For example, if you see on this one, 2015 data, that means on 2015, these are the places where the police killing occurred, right? So if I just plot the latitude and longitude values where the police killing occurred only for 2015, I'll get this one, right? Then if I repeatedly do it for 2016, 17, 18, 20, 22, right? For over the years, I will see how the police killing took place, where the police killing took place, right? Did you understand? I want to create a GIF. The GIF will show me that every year how the police killing changed, right? So let me show you the GIF. See, I want to create something like this. See, every year I am seeing where the police killing occurred, right? See, every year it is shown. So that means I have to catch a still picture for every year. Then somehow, by some means, I need to stack those up. Okay, that means I got a picture of 2015. I got another picture of 2015. Sorry, 2016. Okay, that means let's say this is the data. This is the geoscatter plot. Geoscatter. This is for 2015. Then I have another for 2016. Okay. Then I have another for 2017. In this way, I'll have several plots, right? And by some method, by some slideshow, I have to jump from this one to this one, from this one to this one, from this one to this one. Clear? In this way, we actually create a GIF, and again, it will start from this one here. Okay. So first thing is what? To plot the geoscatter for each year, right? So what I've done is that I've created a for loop for length 1 is to years. Okay, there are how many years total? See, 2015 to 2022. I'm observing from 2015 to 2022. So that's why I'll run the loop for each of the years. So the current year will be current year, then subset. Subset means what? Now I'm just collecting the data set of that. For example, when I is equals to 1, that means 2015. Now df dot year. So you see df table. Is there any years? Mm, Where is years? There should be a column years. Oh, okay. So when you write df.years, probably what the silly. Then I've downloaded the wrong file here.
সেটা থেকে ডাউনলোড করবো।
Hmm?
স্যার,
Yes.
না স্যার, না স্যার, ঠিক আছে।
Wait. This one
Sir,
was
yeah, would you please repeat the part why we were using scatter in the GIF part and
okay,
not
wait.
the lines?
Yeah, okay, I'm repeating again. Wait. Yeah, I need that. এখানে আসলে এটা আমাকে ভুল ফাইলটা দেওয়া হয়েছে। আচ্ছা, তোমাদের ক্লাসরুমেও তো দেওয়া হয় নাই সেট। Okay, I'll provide you the uh, right file. Okay, this police shooting, this doesn't have any year, sorry, year column. Okay, so I have to provide you the actual file later. But it was supposed to work. Okay, so anyway, so I was saying, what was the question? Why we were using scatter plot, right?
Uh,
Uh,
yes, sir. I mean, you were saying that we were trying to build an animation type thing, but then you also said that we were trying to find out the points where shooting occurred. So, like, why are we using the scatter plot here?
okay, see, what do we get from scatter plot? See, for example, this one. This was plot. See, this is simple scatter plot. Okay, the cities of Bangladesh. Only see here when I provided the latitude and longitude value. Here, latitude and longitude values here. I got see the point. It is showing you the Dhaka here. This point is plotted here. See, there is Sylhet here. There is Chittagong here. Okay, these points are plotted using scatter plot. See, if I change the way this plot looks, see this one, these three are the latitude and longitude values of the cities of the three cities, Dhaka, Sylhet, and Chittagong. Now see, if I use geo plot, okay, see what happened. See only see these 2 points are connected. Okay, you plotted these 2 points, and then it now they have connected these 2 points, right? Just like your normal plot. In your normal plot, when you plot some points, those points are connected. But in your scatter plot, the points are not connected. They are just plotted over the map. Clear? So see, in this GIF, that in this animation, see, we are just pointing the plots. We don't want to we don't want to see any link between these points. Okay, we don't want to connect the 2 points. Okay, so for example, if I just want to plot 2015. I just want to see this 2015 frame. Okay. On 2020, on 2015, where the killing occurred are plotted in this map. Okay. I don't want to see if these 2 points are connected or not. There's no need to see whether these 2 points are connected. Okay. You cannot connect these points. It will be a very mess if you just connect these points. Okay. I just want to observe where the killings occurred. That's why I just need to see the points. Clear? So that I've got the point for 2015. In this way, I'll get it for 2016, then 17. In this way, I'll plot up to this frame, this each frame. For every year, I'll plot each of these frames. Okay. Did you understand? Then I will stack up those frames, and one by one, I'll change the frames. Did you understand?
Yes, sir.
Okay. Now let me go back to the code. Okay, so the file, it has some error in the file. There is no year column. P data thread type cities. कोई गया. There should be a column named year. Okay, it's not provided to you, so I'll provide it. No worries. But just let us understand the code. Now see, now I have see df.years. That means when. And now I'll just work with the data that is corresponding this 2015. When I have written df.years equals to current year, that means now I'm working with this 2015 data. Okay, now I've just created a geoscatter plot. Clear? Now I have this geoscatter for the 2015 data. Okay. Do you understand this one? For 2015, let me see. I have taken this subset. That means only the data that are corresponding to the year 2015. I have taken those data. See, just 2015 data here. I have taken the latitude and longitude value, this subset dot latitude, subset dot longitude. Okay, now বাকি বলে okay, anyway. So did you guys understand this one? That means we are just plotting for 2015 now. With this one, see subset dot latitude, subset dot longitude. Subset means what? Only the data that are corresponding to the year 2015. That is current year equals to 2015. Now we have I equals to 2015. That means current year equals to years of I. That means subset will be the values that are corresponding to year 2015. Then we have used the word geoscatter. You see subset, we have provided the latitude and longitude value, and then we have created a geoplot, sorry, geoscatter plot. Okay. Then we have this, let's say we have this plot here. Now we have to capture the plot as an image. And how to do that? We have to actually use this get frame. And GCF means get current frame. And which is the current frame? That is this one, this geoscatter, this plot. Okay, so get frame means you have to take just the frame within the axis. We don't take the axis. Okay, so for example, this one. If I look at this one example, when you use GCF, that is get frame, you only take these values, whatever is inside the axis, not this language, these values or these latitude or longitude names. Okay, not the x-axis and y-axis values. We just take whatever is inside this axis. Okay, just the frame. Okay, so to get that, you have to use get frame GCF, that is that get current frame, and then convert it to from a frame to an image. Okay, then I am equals to frame to image. If you just provide this frame, it will create a frame to image. Then you have to actually you have this image file, and then you have to actually find the index, that is RGB to index. You have convert it to an index file. Okay, then you have this index here, then the values corresponding to those the RGB value corresponding to those index. Okay, you have when you are converting this to an IM frame, it actually gives you a 3D matrix having the values of RGB color. Okay, the values of R, the values of the green color, and the values of the blue color. So if you just convert it to an RGB to int, it will just convert. It's the similar thing like sub to int. When you used to use the function sub to int, what it did, it changed the subscripts to some indices. The same thing happens here. When you are using RGB to int, it will create some index, and the values of the RGB values corresponding to the index will be stored in this CF. Then to create the the GIF file, you have to again create a, see, if I is equals to 1, that means the first one, that means the first frame. Okay, uh, in your GIF, you see the start from 2015, then it continues to change, and when it reaches 2022, see, when it reaches 2022, it goes back to 2015. So that's why you have to first create the first frame, that is for the one 2015. So I equals to 1, that means the first frame. Okay, that means the geoscatter value corresponding to 2015. Okay, so this you have to provide this index, then the values corresponding to this index, then the file name, and what type of file. It should be a GIF file, so GIF, and this loop count. Okay, so loop count should be infinite. Why? Because every each the loop will be uh, how should I say, the loop will be uh, run infinitely. Okay, that what happens in GIF, right? Every time it goes back to the last frame, it again comes to the first frame, then it loops around infinitely. So the first, when you are writing the first frame, I am right, you have to give the loop count as infinite, and delay time, it is just the delay between the two frames. Okay, then, and for the rest of the frame, that is else, when I is not equals to 1, that I is equals to 2 3 4, that means for the rest of the years your other things will remain same, but here give should be write mode. That means now the write mode should be appended. That means you are appending over the first frame, the previous frame. Okay, the write mode should be append, where the previous frame was 2015, that means the 2016 should be appended over 2015. 2017 should be appended over 2016. Okay, so the write mode should be appended, and again we have the delay time, and then pause. Pause means once, and when your one frame is shown, then this is actually redundant. You can actually skip this one. Okay, so then after that, when you run this one, you'll find GIF file like this. Is it clear? Any question on how we have created this GIF file? So I don't have I don't actually have the correct file. That's why I cannot run this code. But when you input the correct file, you can actually do this in here. Is this clear? Any question? Okay, so if you don't have any question, we can conclude the class here. So just put your IDs and then you can leave in the chat. Put your IDs in the chat and you can leave. Geoscatter is not working in my MATLAB 80. So is Geoscatter not available in MATLAB 18? I'm not sure about that. I have to check. Yes, Geoscatter is not available in MATLAB 18. So actually you have to get the updated version of MATLAB to plot the geoscatter. You have to use the geoscatter, you have to have the updated version of MATLAB. Unfortunately, MATLAB 18 doesn't support geoscatter. That's what actually I'm saying, that for the earlier MATLAB versions, some things don't work. That's why we try to show the things that are actually uh, কি বলবো? So we actually try to show things that are compatible for all the MATLAB versions. That's why, for example, we have used the GCF. Okay, so GCF, GCA, the GCF, GCA. These things works for all the versions. So if you just directly use some things, okay, these things may work on some versions but not work on the other versions. Okay. For example, you see Geoscatter is not working on 2018 MATLAB 2018. Okay, so you actually to use this geoscatter, you need to have the uh, 2020, I believe 2021 or 2020. Maybe it was introduced on 2020. Oh yeah, it was introduced on 2020. So there is some workaround for the other versions. You can actually look at those things. Okay, so if you don't have any question, we can conclude the class here. So I'm asking again, do you have any question? Anyone? Okay, so if no question, Assalamu alaikum. We'll end it here.
Sir.